We've been doing some work recently looking at ways in which you might look at correcting a genetic defect in an embryo. And this is a very fascinating subject for multiple reasons. It's a little bit controversial ethically, it's technically challenging, but it also is something that holds a lot of clinical promise and we think is worth looking at. At the moment, if a family is at high risk of passing on a particular inherited condition, there are a few options available to them. They could just choose not to reproduce at all, remain childless. They could get pregnant naturally, have a prenatal test, but then if the fetus is found to be affected, then they have two unpleasant choices. Either go through the pregnancy knowing that the child will be born with a serious condition, or terminating the pregnancy. And you can appreciate that neither of those is really ideal. Another possibility we've had with us now for about 25 years and do a lot of within IVIRMA is pre-implantation genetic diagnosis, where a couple goes through an IVF cycle, several embryos are produced, each one is tested for the particular inherited condition that that family is at risk for, and hopefully we find at least one embryo that's unaffected. That's transferred to the mother, who hopefully becomes pregnant and begins day one of her pregnancy knowing that that baby will be unaffected. She won't have to think about a pregnancy termination or the birth of an unaffected child. The only problem with that approach is that some patients don't produce any unaffected embryos. In fact, about 15% of all the PGD cycles we do, we have no embryos available for transfer. They're either all affected, or maybe we found one that was unaffected, but it just stopped growing and so was not viable. So the idea is that maybe you could correct a genetic defect and therefore all of the embryos would become available for transfer. You could potentially argue that ethically that might be preferable, since no human conceptions would then be being discarded. But of course there are contrary ethical arguments as well, because you would be interfering with the actual genetic sequence within those embryos. And because they're embryos, whatever change you make will be in all the cells of those individuals, including the future sperm and egg cells. So the changes made could be then present in the human population forever after. And of course that's something that has to be carefully ethically considered, and the public as a whole needs to be comfortable with that if it's ever going to be done. Right now, we're not at the point where we would ever consider doing that, because at this point, what we're most interested in looking at is the safety. Can this be done reliably? Can it be done safely? And can human embryos really deal with this kind of genome editing? It involves breakage of the DNA, and that's a challenge to the embryo to then repair that breakage and incorporate the correction that we want to make to change the mutant gene back into a normal gene. But that's something we're working on, and hopefully we'll soon understand whether this is something that could reasonably be done.